what should we talk about today?
Requirements.
Oh my gosh, more requirement stuff. Okay, well let's take a look. Let's see if we can remember where we're at, shall we? Okay, so we're doing that iteration stuff, right? So it's not like we just magically sit down, crank out some code, and bam, we're done, right? We've talked about this. A much better way to go about doing this is to take a look at what you have to do, break off a small part of it, work on it, and then what do we do with it? Show it to the customer, right? Say, hey, is this what you want? And what are we expecting the customer to say? Like our mom would, right? That's the best code ever. I'm so happy, right? No. Hopefully they'll say that it's in line with what they're looking for, right? Best case, they say perfect. That's exactly what I'm looking for. More realistically, they're going to say, yeah, good. You know, now that I see it, now I know what I want. And it's a little different from what you've done. But that's cool. We're all good with that. Okay. So iteration. So we expect to do this over and over again, right? So in order to produce the final product, there's going to be multiple iterations where we break off little chunks and work on it. Okay. We want to keep our iterations pretty short. Roughly how long is an iteration? How many days? 20, right? And once again, that's a rule of thumb. Look, it could be a little bit longer, it could be a little bit shorter, something like that, but we're saying 20. And 20 turns out to be roughly 1 month, right? As far as working days in a month. Okay, cool. Why do we want to keep them short? If we keep them short, we can handle the real world. And in the real world, weird things happen. What's going on up in New York City today? There's a snowstorm to end all snowstorms, right? Do you think there's software development projects going on up in New York City? Well, there was yesterday. What's going on today is a little bit of a question. But stuff like that happens, right? And let's take a look at your schedule. Where did you put snowstorm in there? No place. You can put it in there anyway, right? So things do happen. So if you keep them short, you have the ability to react quickly when things like that happen. Short iterations will get you feedback sooner, right? Because you'll have something to show your customer, right? You won't be waiting 6 months and then showing up and going, hey, is this what you want? Because we always know what the customer's going to say. They're always going to say, no, that's not quite right. So if you do it in a short one, you get that feedback and you're able to make the changes a lot quicker. And also, look, you know, a team is made up of human beings. And human beings have a tendency to have your attention drift and wander and stuff like that. If you're dealing with a short, hard push, it's like a sprint when you're running. People can run really fast for short periods of distances. They cannot run really fast for long periods of distances. That's why a marathon takes, what, 2.5 hours, 3.5 hours if you're the best in the world or something like that. For a regular person, it takes like 8 hours to run a marathon, something like that. Although the 100-meter dash with Mr. Bolt takes something psychotically short, right? Okay, so that's sort of the gist of it. The shorter the iteration, the easier it's going to be able to keep that team focused on what they have to accomplish, right? Longer, then all of a sudden things start to drift, okay? You also want to keep your iterations balanced. You won't want to overload it or anything like that. And one of the key things that you have to realize there is that there's a bunch of things that you're going to have to work into an iteration, and this is actually sort of a key point here. So what's going to be an iteration? It's all going to be new code, right? Just brand new features that you're going to be working on. And the answer is no. There's actually going to be a lot of junk that works into every iteration. So there's going to be changes. Because remember, last time you went to the customer with your code, what did the customer say? Do you want to have changes made?
Yeah.
Well, when are you going to make those changes? I'm going to wait until the tail end and this magically. No, stop. When you get feedback from the customer, you'll probably go back in the next iteration and make those changes. So that's one thing you're going to be doing. Of course, you're going to be adding new features, because that's wonderful. You're going to be dealing with bugs. Are bugs going to show up? Yeah, big time. And people on your team are going to get distracted, or going to get called off and do other sorts of things. So, you know, when you're putting this iteration together, it's not a really sweet, clean, go ahead and work on this brand spanking new feature and get it done type of thing. There's a lot of other stuff that's going on in the environment that you have to account for. Okay? Jeez. What was tricky to begin with just got a little bit more messy, right? Okay. So, and this is a critical issue here. Does your development plan account for reality? Here's a very, very famous saying. Okay? No battle plan survives contact with the enemy. So in other words, create the best plan in the world. And the very first time you throw it in and start to work on it, something's going to happen that you didn't account for, and you can just throw that plan away, is the gist of what the saying is saying. So, right, we're making these iterations, we're identifying which user stories we're going to implement. We know in 20 days we're going to have this code pop out on the end. Yay, go for it. That's your battle plan. palette. Once you start working on it, things are going to change. Okay? What issues do you have to account for when you're creating a software development plan? Who's going to be working to implement the software? Is it going to be robots or people? People. Okay? What kind of things can happen to people that would cause them not to do what you wanted them to do?
Sick days.
Sick days? What else?
Death.
Death? Death is, well, you know, it's a setback, but let's not really think of it as a, okay, so that's the issue.
Mass power outage.
Massive power outage. Like up in the Northeast, like when the big snows come, they lose power. Everyone's screwed at that point in time. So, acts of God, I guess is what that would be. You really don't want us to do this. But what else do we have to worry about? What do people do when they get, when they've been working for a while, they're sort of tired and they'd like to have a break? They take a vacation. Can you make them not take a vacation? You can. And how's that going to make them feel? Anger, bitter, resentment. Talented, skilled software developer get angry and bitter. What do? They go get another job that probably pays them more, right? Damn, that didn't work out so well. Okay, what else? No. So your developers, assuming that they come into the office to do work, okay, let's say they do that, how are they going to get into the office? In most cases. Well, congratulations. But how will they actually physically get to the building? With a car. Hey, are cars perfect?
No.
Do cars always work?
No.
Absolutely not, right? So stuff could happen with the car, right?
Like in Segway.
Now, although I often recommend that you hire only monks to work on your software development projects, unfortunately sometimes people screw up and they hire people who have like families. Right? Families. And families can never possibly be a good thing. Why not?
They get in the way of it.
They do. Oddly, sometimes people prioritize their lives incorrectly, right? And like sick, like children can cause problems, or sick spouses or something like that. I mean, really, it is a matter of priorities, but sometimes people working on people do wrong. So let's see what we're dealing with here. Paperwork, which is something that does have to be done as part of a project, is things that have to be done. People on your team are going to have to take care of paperwork. You're going to have to take care of paperwork and stuff like that, which is fine, but it's not really moving you forward as far as that software development stuff goes. Sickness, we talked about that one. Software upgrade. You know, so you're going to be working on a system, you're going to be using like a database, or you're going to be using a laptop or something like that. Hey, great, it's running, Windows 8. Ooh, look, hey, Windows 10 is available. And we've decided as a company to upgrade everybody's laptop. Fantastic.
How does that affect?
Could you not do that during my project? Well, because we just need your laptop for like a day. All we need is for a day. And we think the upgrade is going to go pretty well. Pretty well. But first we have to back your laptop up. Then we have to do the upgrade. And then we have to restore your stuff. Oh my God. So that day is gone, right? Jeez. Oh, by the way, we had a problem. But it's cool because we ordered a new hard drive. Okay? It should be here in 2 days. And then we'll, what? No. Okay.
They're not even accounting for the time to learn the new upgrade.
That is the, that's not the job training. Equipment failure. Does equipment fail? You ever have a laptop die on you?
Yeah.
Were you backed up?
Yeah.
Yeah, pretty much. No matter what, if you have something that you're using that fails, look, maybe you've got a backup and stuff like that, but no matter what, you have to restore the backup, right? What a pain in the butt. And by the way, this will happen exactly at the wrong point in time. Okay? Holidays. Really? Christmas. Well, what are the holidays? So we've got Christmas, Thanksgiving. Those are the big ones, right? What else we got?
Easter.
Easter's another big one. Now we go to the scrappy ones. What? 4th of July.
New Year's.
New Year's. Memorial Day, and then the flip side of that is Labor Day. And we just had MLK, and MLK has another compadre who was called Columbus Day.
President's Day, right?
President's Day. It really, it depends on the company you work for and stuff like that. But here's another absolutely fascinating thing. Let's see, my favorite thing was when I worked for a German company that was located in Bavaria, because the company in Bavaria, they got German national holidays, they got religious holidays, and I think they got like year holidays also. They got time off all the time. The other interesting thing is when working with developers who were in India, India has a completely different set of holidays. So from a U.S. perspective, we know our holidays, right? We got 4th of July, in India, they've got a whole different set of holidays. And dear God in heaven, if one of your Indian software developers decides they're going to get married, How long does it take to get married in India?
Isn't it like a month?
It's easily a month. There's travel time, and you spend time with his family, and you spend time with her families, and then there's the ceremonies, and then there's the church. But no, there's a chunk of time. So, no matter where the software developers are located, there could be cultural issues that perhaps you haven't accounted for in your swell little program. So, things to worry about there. Vacations, we talked about that. Oh, and car problems. And car problems could be any sort of problems. My hot water heater broke, my roof caved in. I can get evicted. Okay, so it's going to be a couple of days before I get in because I got to find support. All right, so the key concept on this is that on any software development project, you're actually dealing with human beings. And human beings and all of their specialness have challenges that show up. You would love that if they were a robot, they would show up and they would work 40 hours a week. 80 hours a week if they do it. But 40 hours a week and they'd be cranking out software during that 40 hours. That would be fantastic and wonderful. Doesn't work that way. What it means for you is when you're trying to figure out when a software project can actually get done, you have to account for this sort of stuff. All right. And that's why we start to talk about what we call velocity. Because velocity is basically talking about how fast your team can move forward. In a perfect world, they move forward at 40 hours a week. Okay, great. They come in, they work, they go home, bam! You're, every day you're 8 hours ahead per software development. The reality of the situation is it doesn't work out that way. So, velocity is measured as a percentage. Velocity says how much of your time is being spent doing productive work. All right. What's interesting is that you have a personal velocity, don't you? So how much of your time currently is spent doing productive work? I don't know, 20%? 10%? Well, it depends. On the weekends, zero. Less than it should be. Would you say you're operating at 100%? No. Every moment not spent in class is spent working on schoolwork? No, absolutely not. Right. 50%? Oh, we're being generous. Come on. You're at best 40%. And I'd say probably more like 30%, but it's really your fault on that one. But you understand the gist of it, right? Yeah, 100% is fantastic. You're the best student ever. The reality of the situation is you're probably operating at like 30%, 40%, or something like that. You've got a life, right? You do weird things like, I don't know, eat and sleep. Whatever that, okay? But it takes away from it. So recommendation is that you start with a velocity of 0.7 or 70%. What does that really mean? That means that for every 10 days that software developer works, he's really only working on your project for 7 days. What's he doing for the other 3 days? He or she is doing other things, right? And other things are as simple as paperwork, going to meetings, maybe doing training, etc., etc., etc. It can be anything, but most importantly, during those 3 days, he's not working on moving your project forward. Okay? And what we're really starting to do right now is we're introducing just a little bit of reality. Okay, I mean, I love math as much as the next person. I love saying, hey, listen, 40 hours in a week, great, I'll be 40 hours ahead at the end of the week. But the reality of the situation is it never works out that way. So if you're going to go with that assumption, you're going to be desperately surprised when you hit the end of your fabulous, wonderful, beautiful, pristine schedule you put together, and you have no software to show for it. And you're like, wow, what happened there? This is exactly what happened. Your velocity was off. Okay? You'll adjust your velocity at the end of each iteration. In other words, look, maybe you have a really good team. A bunch of losers who don't have anything else to do with their life except do your software development work. Fantastic! This is the best thing that could ever possibly happen, right? Cool! That means that their velocity is like maybe 80% or 90%. Wow, that's great. Or you got a bunch of young kids just out of college. Yeah, they're working for you, but they got other stuff going on, and that club scene. It's really pretty cool, but unfortunately it goes to like 4 in the morning. So yeah, they'll drag their butt in the morning, but they're not really good until like 1 or 2 o'clock in the afternoon. And your velocity goes down to 0.6 or 0.5 or something like that, right? So you have to constantly be adjusting it, and arguably your velocity would adjust based on who's on your team. Remember, we've had some discussions about adding people to your team. You would think if you added people to your team, it's going to have an impact on the velocity, up or down. Guys, that's what velocity is. It's a real-world consideration for when you're trying to figure out when the heck your software is actually going to be done. So how do you use velocity? Well, we have a term, we should figure out how to use it. Okay, so what you're going to try and do is you're going to apply velocity to what you're working on, and the whole goal is here is to get this realistic estimate there. Okay? You've got a numeric estimate, right? That's going to take me 10 days, that's going to take me 15 days, that's going to take me 5 days. Fantastic. But that was just you pulling a number out of the air. It was cool. So now that you have that number, let's take that number and apply a little bit of real world considerations to it. So how do we use velocity? Well, first off, we say days of work, which is arguably what your estimate was. We divide it by the velocity, and that's going to give us the total number of days that's going to be required to get it done. All right, well, this seems actually like pretty straightforward here. Now, interesting enough, 30 calendar days turns into 20 working days. We know about that, right? And then if we apply our 0.7 velocity to that, it turns out in a month, what you really have is about 15 days in which the people on your team are actually going to be doing software work that's going to move your project forward. Damn, that's like half a month, right? That's like 50% of the month. Okay? Well, here's the thing though, you can be confident in that 15 days. You'll really get to 15 days out of it. Well, if you've got confidence in that, then you can start to get a real grasp of when your software project is actually going to be done. Alright? Alright. So let's see how this all works out for our stuff here. So if you recall, we have a series of user stories that we're working on here. And we have estimates for each one of these, right? Paid visa, 10 days, we said. Book packages is 15. Travel as 5. Book a room is 10. I think there might be one more. Yep, there it is. 3,000 concurrent users is like 20 days. So remember this is our old friends. We put these together. These are our best guesses for how long this is going to take and stuff like that. We're going to add them all up, which we've done. We've said this is how long it's going to take to do this software project. But now, based on our new knowledge today of velocity and stuff like that, we know this 10 isn't really 10, is it? It's actually going to be a bigger number. How long will it take us to get this feature done? Well, if we work velocity into it, it's going to extend out, right? Because 10 days, we know that if they work on it for 10 days, we know our software developers are only going to get 7 days worth of effective work done, right? It's going to take 10 effective days to get this little bugger done. So we're going to have to do a little bit of calculations here. So let's do that. All right, so our initial estimate was 10. Yay! If we take a look at a velocity of 0.7, it turns into what? That's a bigger number. Well, and of course, book packages was 15, but now turns into 26, and you see how this one goes, right? So we're applying a velocity to our best guess estimates for how long it's going to take. And what we're finding out is we're finding out exactly, realistically, how long it's going to take our software development team to actually pull that one off. So it's not good news by any stretch of the imagination, but it is important news because those are actually really realistic numbers. Okay? So we had said that it was going to take us 115 days to complete the software project. Okay. But it turns out it's actually a little bit closer to 200, isn't it? 198 is realistically what it's going to take. But I'll tell you what, if I'm talking to customers, I'd much prefer to tell them it's going to take 200 days. Then show up and say, yeah, we'll have it done 115. Because what's going to happen is I'm going to hit 115, and what am I going to have left to do? Like half the project, right? That's going to be an awkward customer conversation. Well, I was a little bit off, right? Oops.
A little bit off, like 50%.
Exactly, right. So velocity is a critical factor here, guys. And what it is, it's just a basic understanding that when you're dealing with people, they're not going to be operating at 100%. So you have to account for that. Now remember, the 0.7 thing is made up. We just pulled it out of the air. It's a good guess. But whatever team you're working on is going to have their own unique velocity, and that's something that you have to calculate based on who's on your team. All right, so let's take our iteration example. Now this is what we put together last time. Remember? We said, hey, okay, 115 days. We're going to do it in 3 iterations. How's this going to work out? I think we said that we had, I think we had 40 days. Remember, it's 2 developers, and it's a 20-day cycle, so we could put 40 days. Okay, is this all making some sense here?
Yeah.
So we did pay with Visa, book a room, support 3,000, and those were all high priority ones. We got that taken care of. Iteration 2 was book packages, review stay, and choose the view. Poof got in our iteration 2. And on our iteration 3, we had book a boat tour, order trip DVD, arrange travel, and I think we tucked in order room service, and bam! And this was pretty, wasn't it? Yeah. It all fit, and it was all there. get 3 iterations, and we can talk to the customer about this and say, we're going to have all of your software done when we're done with iteration number 3, right? That's engineering beauty! But it turns out it was wrong, right? And why was it wrong? Right. So can we actually get that work done in that time period? Maybe. Realistically speaking. I mean, it's still beautiful. I don't want to take away from that. It's gorgeous, okay? But it is wrong. And it's wrong because it's not accounting for the real world, okay? All right, so what are we going to have to do here? Let's take a look at this. All right. So we have 2 developers. We know that we have 20 days in our iteration, right? Basically 1 month, okay? And we know our team's velocity is 0.7, okay? So that comes out to be 28 working days. Okay, that's cool. I can live with that. So that's not actually what I wanted, because I think I was at 40. Wasn't that 40 with 2 people? 40. So we just dropped that down to 28, dang it. Okay, and I have 3 iterations, and so that means I have a total of 84 days to work with, right? And what was the magic number for this particular project? How many days was it going to take? Yeah, just about 200. Oops. So I have roughly half-ish, actually even less than half, of the available time to pull this one off. This is a 10 pounds of stuff to fit into a 5-pound bag. Okay. So let's go back and take a look at this again and see what we can do here. So we still have our 2 developers, we still have our 3 iterations. We're going to have to do something a little different here. Okay. So what was this? Hang on. We've got 28 working days in an iteration on it. So we've got 10, right? And 20. Now that's 30, right?
Yeah.
So that's a little bit too much, but it's pretty close, right? All right, let's do it around. We'll let that one go. Okay. Here we have book a room, which is 10, and book packages, which is 15. So it takes us up to what? All right. So I don't think we have nothing else that's going to get us any closer to that. So that 28 is our magic number, right? So 25 is pretty close, and maybe because we went a little bit over the first one, we can do a little something else on this one, right? Okay. Down here we got 15 for choose a view, and we got 10 for review stay. So once again, that's going to get us to 25. Oof, I think that's it, guys. I think realistic, real world looking at it, this is the features that we could implement in 3 iterations, right? So at the end of the 3rd iteration, we can tell our customer, look, I can say with actually a great deal of confidence, this is the software that my team could implement for you in this amount of time. That make sense? Right, and you could say that with confidence. The other one that we had where it all beautifully laid in was gorgeous, and on paper it looked really, really good. And the customer was actually getting more features under that one, right? But the challenge is that it wasn't going to happen. Okay, because of a bunch of real world concerns. Snowstorms, sickness, holiday, car problems, all those things were going to conspire to make it so we weren't actually able to deliver what we wanted to deliver. Okay. So, what are we not going to be able to deliver for our customer? Well, book a boat tour, order the trip DVD, arrange the travel, and order room service. Okay? So this is what we're going to have to tell our customer. Hey, you are not going to get this in our milestone 1.0 product. I feel very comfortable. I am going to be able to give you milestone 1.0. I'm very comfortable telling you it's going to be able to do what? Pay with Visa, MasterCard, PayPal. You are going to be able to book a room. You are going to be able to book packages and stuff like that. But these features are not going to be in that first version of the software. Okay? So, customer may blow a gasket. I don't know. All right? It's really up to them to make a call on it. But we need to be straight with them and let them know what they're not going to get. Okay, how do you deal with angry customers? Okay, well, one way you can do it is we could add another iteration, right? There's nothing magic about the 3 that we have. We could stick a 4th in there. If we do that, then we boost our hours up to 112. All right, what? Better than where we are right now. It's going to take longer. So that means the customer is going to have to be willing to not use our software for another month, basically, right? Really comes down to what the customer's up to, right? Well, were you trying to open up your shack on the pond right at the beginning of the summer season, so you needed to have it in May?
Yes.
Could you wait till end of June? Does it make any difference for you? Customer has to make the call on that. One of the important things we probably have to do is explain to them, hey look, just because you're not getting the features of milestone 1 does not mean that they've been lost. They're not going away. They're just delayed. You will get those features. You just won't get it on day 1. That's an important thing to tell customers. Because the customer goes, oh my God, it's not there. I'm never going to get this. Stop. No, you are going to get it. You just don't get it right off the bat. And then, of course, the third thing is you can always show them how you got your numbers, right? When the customer says, this is garbage, you're lying to me. I know you could actually get this all done if you really, really wanted to. If you'd work your team harder, you could make this happen. So you can back off. You can say, no, that's not possible. I will show you how I calculated my numbers. If you end up doing that, you only end up doing it once, because nobody really wants to go through your calculations with you. But if they do, go through it once and you're done with it, right? So a lot of different ways to handle angry customers, because there are angry customers out there, okay? But this can all be done. Get them taken care of and your life is good. All right, what did we cover today? Sadly enough, we talked about reality, and that's never fun, okay? We talked about velocity. So now you know what velocity is. The velocity is basically how you bring the real world into all this stuff you've been doing as far as coming up with your estimates and your iterations and all that pretty stuff you've been doing on paper, which had absolutely no basis in reality. Now what you've done is with velocity, you've worked reality into it. So you have more confidence about both the numbers that you're creating for your estimates and also for the schedule that you're putting together that you're actually going to present to your customer. We applied velocity to estimates, and we showed what happens when you apply velocity to an estimate. Does it get smaller or larger? It gets larger, and it might get really a lot larger, right? But that's very, very important to do. And arguably, you want to apply velocity to your estimates as early on in the process as possible, right? You really don't want to be doing an awful lot of planning using those estimates that aren't real. Okay? So applying velocity as soon as you have the estimates is often a very good idea. And then we use velocity with iterations. And we discovered when you use velocity with iterations, what it actually means is that you're going to be able to get less work done in the amount of time that you have. Which means that you're going to have to probably have some relatively painful discussions with your customer and explain to them that they're going to get what they want, just not maybe when they want it. Okay. Oh yeah, there was one other thing I wanted to talk to you about. What was it? What we're going to do next time. We'll do user stories and tasks, we'll do burn down charts, and we'll do tracking tasks. But now that you've put together all this stuff, and your team's off and running and doing it, are you just going to hand it to them and say, great, and I'll talk to you in a month and it'll all be done? Yes. Yes, because you've got the best team in the world. Absolutely not. Okay. Somehow you're going to have to find a way to stay on top of this madness that we call software development. There's a lot of different moving parts, a lot of different things. And oh, by the way, can things change during a software development project? No. So you need to have some way to stay on top of that. So that's what we'll talk about next time. That should be pretty interesting. One more thing is your homework. All right, good news! The Lakeland Hospital System has finally purchased a computer. It's the beginning of the new century. What the heck? Let's go ahead and do that. Now, this particular computer has one programming language on it. Guess what it is? Python. Yes! And for some odd and strange and unexplained reason, they've reached out to you. And they said, we'd like you to create for us our patient registration system that we're going to use in the emergency room. So when sick, damaged, and dying people drag their body in through the door, you'll sit down and have talks with them and collect their name, their social security number, their address, date of birth, all that sort of stuff like that. Fantastic. And then you'll do stuff with it. And then you'll print stuff out. So what's your actual assignment? Well, good news, if you take a look in Canvas, I mean, I did a beautiful job. I created an assignment, and so when it was due, and all sorts of stuff like that. And apparently you can't find any of that. But you can find, under Files section on Canvas, you'll find something that says homework number 1. It's a PDF file. It'll contain all the valuable information that you need to read in order to possibly have a chance of turning in a successful homework that will get you points, which is good. No points is bad, points is good. Okay? So the project's due 2-3 at the beginning of class. I think I'm giving you like 2 weeks to get this thing done. Couple notes of caution. First note of caution, I said, well, before I sign this, I should probably do the top, just to make sure it's all cool. And good thing I did, but separate issue on that one. This should probably take me about 15 minutes to do. An hour later, I had discovered things about Python that I did not know. So if I discovered things about Python that I did not know, I have a feeling you may discover things about Python that you do not know. This is not a really hard homework, okay? But there's probably one or two things in there that may throw you for a little bit of a loop, so to speak. So when you're budgeting your time to get this done, Monday night would be the wrong time to do it, okay? Because I think you might get just a tad bit screwed if you do that. I'm just saying. Look, I thought I was going to knock it out in 15 minutes, an hour later I was still cranking on it, okay? So you may encounter things that you did not anticipate. I think your toolbox has all the tools that you need to be able to do this. There's no problems with that. Just Python is a wicked mistress, and you may get surprised by one or two things. So just give yourself a little extra time. Once again, not hard to do. So just make sure you got time. Point number 2. I am unusually cruel. And because I'm trying to introduce you to the real world, I'd like to remind you, in the real world, there's joy and happiness in your life when you're given an opportunity to create brand new software from the ground up, which I am presenting you with an opportunity here, right? Now, in this class, there's actually 4 separate homeworks. And to make your overall class experience better match the real world, what I'm planning on doing is making homeworks 2, 3, and 4 build on top of this. What that means for you is that you're going to be living with this code for some time. So should you choose to just throw it together, slapdash, and no comments, no clever selection of variable names or anything like that, I don't care that much. A little bit of care, but not that much. But you may care a lot as you work on homework number 2, 3, and 4 and go, what was I doing there? Okay? So you're not only birthing this code, but you're preparing to raise it. So I just share with you a note of caution. You make your own decisions on this, but poor decisions could come back to bite you. Are there any questions? I can't remember the homework. Where's that? All right, are we good to go? Fantastic. Why don't we plan on getting back in about 15 minutes, which will be 5 minutes until 9, okay?